If you find it difficult to balance redox reaction, this video is for you. It is not hard, just follow me in this video. So in this reaction, we have MnO4 minus iron 2 plus, Mn 2 plus, and Fe3 plus. Now to balance this equation, we're going to split this redox reaction into two. We split it into oxidation and reduction. Now, first thing we need to do first, which of these species is undergoing oxidation and which one is undergoing reduction? Iron is undergoing oxidation. Why? Because iron oxidation number has increased from +2 to +3. MnO4 minus is being reduced. Manganese ion is being reduced. So now for the reduction part, so it means mag. So to determine how many electron it is gaining, we need to derive or determine the oxidation state of manganese in this reaction, in this compound here. Okay, so MnO4 minus, that will be X plus oxygen minus 2 equal to -1, because the oxidation number of a polyatomic ion is equal to the charge on the ion, because this minus is for everything here, is for all of these atoms there. So X minus 8 will give us -1. X is -1 plus 7 plus 8. X is +7. So the oxidation state of manganese in this ion, this polyatomic ion, is +7. Now it has moved from +7 to +2. So it means it gained 5 electrons. So MnO4 plus 5 electrons. It gained 5 electrons because it has moved from oxidation state of +7 to +2. So that is reduction. At the charge balance, okay, we have -6 on this side and we have +2. For the oxidation, it is balanced for the oxidation. Then for the reduction, the charges are not balanced. So to balance the charge, the question says balance this in acidic region. So that means, what is the ion that is responsible for acidity? Hydrogen ion. So we're going to introduce hydrogen ion on the reactant side. We are balancing this redox reaction in acidic medium or solution. So now look at this now, and I said that we're going to introduce hydrogen ions. Okay, now on this part, let's change the color. On this part, I have -6 charge. Here I have +2. So how many moles of hydrogen ion? Remember that hydrogen ion is positively charged. So how many moles of this should I introduce to the reactant side so that I can have a balanced reaction? So I'm going to introduce 8. All right, we have -6 here and we have +2 here, and I want the charges to be equal. So to make the charge equal, I will introduce a charge of +8. So that will be +2. That will give us +2. So 8 mole of hydrogen ions plus this 5 mole of this electron. Now something has to be done, okay, to balance hydrogen on the product side, because you've introduced hydrogen to the reactant side. You then need to balance the hydrogen on the other side. 2 times 4 or 4 times 2 or 4 multiplied by 2 will give you 8, and you have 4 atoms of oxygen and 4 atoms of oxygen. So it is balanced. Now the next thing we do is to compare the two reactions, compare oxidation reaction and reduction, and the reduction also, and balance the ions there. So I know I'm taking this thing slowly. I'm taking this slowly so that you can get this thing right once and for all. you get it right once and for all. So we have balanced the reduction side. Now I'm going to bring the oxidation reaction here. So next step is this. These electrons need to cancel out. The electrons have to cancel out. They have to. So how do we make them cancel out? We do that by making them equal. So to make the two reactions, to make the electrons in the both reactions the same, we multiply this oxidation reaction by 5 and multiply this reduction reaction by 1. Okay, so let's do that. We have MnO4 minus plus 8 hydrogen ions plus 5E minus Mn2 plus then multiply this one by 5. That's 5 here also plus 5 here also. So this, then the next thing you say, add the reactions together. When we are adding the reactions together, this one will cancel out this. Thank you for watching. See you in the next video. Bye for now.